Hey everyone, welcome back to the channel. Today, we're diving into one of the most mind-bending, fascinating, and mysterious topics in the universe. Black holes. What are they? How do they work? And could they really suck everything around them into oblivion? Let's find out. Black holes are one of the most extreme objects in the universe. But what exactly is a black hole? Simply put, it's a region of space where gravity is so strong, nothing, not even light, can escape its pull. To understand how they form, let's start with stars. When a massive star exhausts its nuclear fuel, it collapses under its own gravity. If the core is massive enough, it can shrink down to a point of infinite density, what we call a singularity. That's the heart of a black hole. Around this singularity is the event horizon. Think of it as the point of no return. Once something crosses this boundary, be it a star, a planet, or even light, it's gone, forever trapped inside. Not all black holes are the same. There are actually a few types based on their size and mass. The most common are stellar black holes formed from the collapse of a single massive star. But there are also supermassive black holes, millions or even billions of times more massive than the Sun. These giants sit at the centers of galaxies, including our own Milky Way. Our galaxy, for instance, has a supermassive black hole at its core called Sagittarius A asterisk, which is about 4 million times the mass of our Sun. Wait a minute, if black holes don't emit light, how can we detect them? Well, we can't see black holes directly, but we can observe their effects on nearby objects. As a black hole's immense gravity pulls in nearby stars and gas, it causes these objects to heat up and emit radiation. We can detect these high-energy emissions like X-rays with telescopes. One of the most groundbreaking achievements in recent years was the first ever image of a black hole's event horizon, taken by the Event Horizon Telescope in 2019. It was a supermassive black hole in the galaxy M87, and it gave us a real glimpse into these cosmic giants. Now let's talk about what happens if you fall into a black hole. The intense gravitational forces would stretch you out like spaghetti, a process scientists call. As you get closer to the black hole, the difference in gravitational pull between your head and your feet becomes so extreme that you'd be stretched and compressed at the same time. This extreme stretching happens because the gravity near a black hole is much stronger at one point compared to just a tiny distance away. Here's where it gets even more mind-bending. Some scientists think black holes might not just be destructive forces. They could also be gateways to other parts of the universe, or even different universes altogether. This idea comes from the concept of hypothetical tunnels through space-time. But so far, it's all just theory. Wormholes would allow you to travel vast distances in a short time, like a cosmic shortcut. However, we don't have any evidence that they exist, at least not yet. So, what's next for black hole research? Scientists are using ever more advanced technology to study these incredible objects. From the Event Horizon Telescope to gravitational wave detectors, we're learning more every day about how black holes form, grow, and affect the universe. Black holes are some of the most mysterious objects in the universe, and we've only just begun to understand them. Whether they're cosmic vacuum cleaners, portals to other dimensions, or something entirely different, one thing's for sure: they challenge everything we know about physics and the universe. Thanks for watching. If you enjoyed this video, make sure to give it a thumbs up, subscribe, and hit the notification bell so you don't miss our next deep dive into the wonders of space. Let me know in the comments what other topics you want to see next.